programs we are going to see in this experiment. So first program, largest number, finding the largest number in the given array, finding the smallest number in the given array. Second one. Third one, pure sorting, arranging the numbers in ascending order, arranging the numbers in descending order. All the 4 experiments we will do. Okay. So we know that sorting of numbers means arranging of numbers either in ascending order or descending order. Okay, so ascending order means smallest number to largest number, and descending order means smallest number to the largest number. Okay, so and we have n number of algorithms for sorting the given set of numbers, out of which for implementing in your ALP we are taking bubble sort. Okay, bubble sort algorithm, otherwise it is known as exchange sort. Okay, why we are taking this is the simplest algorithm which works on the principle of comparison and exchange. Okay, so compare the 2 items and exchange them if they are in the wrong order. Okay, and this exchanging process or the swapping process will be repeated until there is no need of further exchanges for sorting, for arranging the numbers. Okay, and because it only uses the comparisons on the elements, it is sometimes known as comparison sort also. Right. So, and this is the directly I am writing the program. We will analyze it separately. Okay, so this is a program for assembly language ascending order. Okay, so here we are taking 5 numbers. Okay, so which are defined in data segment. So first assume CS code DS data. So we are going to define 2 logical segments, code segment and data segment. Okay, in data segment we are initializing at from 1000H onwards, and we are defining the data 5, 6, 3, 2, 9. Okay, in the later part of the execution you can change these numbers also, there is no problem, but for understanding at the starting we took 5, 6, 3, 2, 9, and that complete set of numbers we are naming that array as list. Okay, then we are entering the code segment, and from 2000H onwards we are going to write our actual code. So move AX comma data, move DS comma AX. So we are accessing the data segment here. Okay, and then we have to define 2 counters. Okay, so which will check the number of comparisons for each and every loop. So we are going to use 2 loops for sorting. So first loop will be taking the largest number, okay, to the last position, right, and the next loop will take the second largest number to the last but 1 position. So like this it will be going. So if we are having 5 numbers, the number of loops we are going to use will be n minus 1. Okay, and in each and every loop we are going to perform n minus 1 comparisons. Okay, right, so straight away we'll go for the program. So here up to definition move ds comma ax, we have defined the data segment. Okay, then the rest of the code we are writing here. So here just check, this is the data segment what we are defining. Okay, so 1000, 1001, 1002, 1003, 1004. So in this data segment, in these address locations we are defining the datas. Okay, in 1000 location 5, 1001 6,
this sort of things along with that tags.
We'll take it.
Save that. No, now faculty is right. I understood what we need to do. Otherwise, every time those particular files are being displaced, they don't know that. Every time over too many process also, better only one process will be. At that time, your headache will also go. Everyone headache will go. They will sign on that particular sheet. That will be there with me. Any file required to me, and ask them directly that I will use. Then come. Now onwards, if anyone is going over and education and those things, frequency along with you. This can be a face that problem. People have kept in their logged it up. That thing we can do it again. How much time will it take?
By afternoon it will be completed. I have the lab. Today we'll wind up with it. Okay, I have. So sorry students, a small a small interruption. Okay. So now so I'm writing the code. So two loops we are going to define. Okay, so where the number of loops for sorting the given numbers will be defined as n minus 1, where n is said to be the number of elements. Okay, and the number of comparisons we are doing for each and every loop will be reduced in terms of n minus 1 factorial. So the total number of comparisons we will be doing is n minus 1 loops we will be having. So n minus 1 loops we will be having, and the comparisons will be n minus 1 into n minus 2 into n minus 1. Okay, so these three parts we can simply replace it by n minus 1 factorial. So n minus 3, like this it will go. Okay, so this comparison we can do n minus 1. Okay, so until this we are performing the comparison operations. So instead simply we can say n minus 1 into n minus 1 factorial number of comparisons we are going to perform. So we require two counters for this, one for setting the number of comparisons, one for counting the number of loops. Okay, so now here CL we will consider for number of loops, and the DL register we will define for number of comparisons. Okay, so first n minus 1 loops we should execute. So number of elements are 5. Okay, so 5 means, so number of loops will be n minus 1, that is 5 minus 1, 4. Okay, so I will take number of loops here. Instead of writing it as number of comparisons, we can write it as number of loops. Okay, so the number of loops we require is 4. Okay, next, number of comparisons. In the first loop we require 4 comparisons first. Okay, so we have moved the same value CL into DL. CL is copied simply to DL register. Next, what we do is first move the content of SI to the starting location. Okay, so SI is moved to the starting location. SI is pointing to the starting location, which is our 1000 in our data segment, right? Next, what we do, move the content that is pointed by the SI register to AL register. Okay, so what is the content that is present in 1000H? 1000H is pointed by SI, isn't it? So now in 1000H our content is 5. So 5 is simply moved to AL register. Okay, so 5 is simply moved to AL register. Next what we do, compare AL comma SI plus 1. So compare AL comma SI plus 1. So here we are performing the comparison operation between the content of AL and the content that is pointed by SI plus 1. So SI value is 1000 plus 1 will become 1001 and the content in that is 6. So the value of 6 and 5 both are compared. Okay, so which one we are doing? We are doing the ascending order. Okay, so ascending order means the last number, smallest number has to be at the first position and the highest number should be at the last position. So the largest value we have to move. So exchange has to be performed in with respect to that. So what we do, so since compare 5 comma 6, 6 is the largest number, we will get the carry. Okay, so if we are getting carry, we are not performing any exchange operation. Okay, so what we do in the next step, we are incrementing the value of SI. Okay, so SI is incremented. Now it is pointing to 1001 location. Then decrement DL value. So DL, so number of comparisons now it is reduced to 3. Okay, and JNZ L2. So JNZ. So we are checking the condition of DL. Okay, so DL is becoming 3, which is a non-zero value. So when it is non-zero value, this statement JNZ L2. JNZ L2. So jump for non-zero becomes true and the control is transferred to L2 location. So where is L2 location? Here is our L2 location. Okay, so now here what we are doing, so AL is loaded with the content pointed by SI. So now SI is pointing to 1001 and the content that is in 1001 is 6, that is simply moved to AL register. Okay, now again next step what we are doing, we are comparing 6 and then 3. So compare AL comma SI plus 1, the content present in SI plus 1. So content in SI plus 1 is, SI is 1001, 1000 plus 1, 1002. The content that is present here is 3. So 6 and 3 are compared now. Now 3 is the smallest number, isn't it? So we won't get any carry. So what happens? This condition, jump on carry, this statement will, this instruction will be false and immediately the next instruction will get executed. So what is the next instruction? Exchange the contents of AL and SI plus 1. So SI plus 1 was 3. So here it will be replaced with 6 and AL is replaced with 3. Okay, and then in the next step what we are doing, this AL value we are moving to the previous location, that is here. So AL is copied and AL is moved here. Okay, so now these two values got exchanged. Okay, next, what is the next instruction? Increment SI. You'll get SI is pointing to 1002. Decrement DL. Now these two comparisons are over and this is a non-zero value. Again we are going to this L2 location. Okay, in L2 location move AL comma at SI. So SI is pointing to 1002. The content of 1002 is moved to AL register. Then perform the same comparison operation. Compare AL comma SI plus 1. Okay, so AL value is 6. SI, the content in SI plus 1 is 2. Okay, so this 6 and 2 will get compared. And again 2 is the smallest number. So we need to exchange the things. So what we do? So here we will exchange it by, in AL we replace it by 2 and in 1003 we replace it by 6. Then again the content of AL is moved copied to SI location. So this is copied, this is copied and pasted here. Okay, next increment SI. SI is incremented. Decrement DL. Decrement DL. Now DL becomes 1, and since it is non-zero value, again we are going to L2 location. Now the content of address location pointed by SI is simply copied to AL register, right? And then what happens? Compare AL comma SI plus 1. So SI plus 1 is 9, okay, and AL is 6. So the second one is number is the largest number, so we get a carry here straight away. Okay, so once we get the carry, what we do, this condition will become true, JCL. So we will go to L location, SI is incremented, okay, DL is decremented, now it becomes 0, and this condition is going to fail. JNZ L2 will be false, and next instruction will get executed. What's the next instruction? Now one loop is over. So if you see here, after completing one loop, the largest number is placed at the last location. Okay, so now we are going for the second loop. Okay, so now decrement CL. Now CL is made as 3, and we are checking the condition of 0 condition for CL. CL is a non-zero value. We go for L1 L1 position. So L1 is move CL comma DL. So CL value was 3. Now the new value of DL will be 3. Okay, and next move SI comma offset. Now freshly we are starting the sorting process again for the second loop. So SI will be pointing to 1000 now. Okay, next the content of SI is simply moved to AL register. Then compare AL comma SI plus 1. So SI is 1000. 1000 plus 1 is 3. Okay, so now 5 and 3 are compared. Okay, so So 5 and 3 are compared. So what happens? 3 is the smallest number. There exists no carry. So this condition will be failed, and these two contents are going to be exchanged. So what we are doing, exchange AL comma SI plus 1. So AL is replaced with 3, and 1005 is replaced with 1001 is replaced with 5. And in the next instruction, that is move at SI comma AL, the value of 3 is moved to E register. Okay. Next, increment SI. So XI will be incremented and pointed to 1001 location. Decrement DL, now it will become 2, and it is a non-zero value. So it will go to L2 location, move AL comma SI. So move AL comma SI. So 5 is simply copied and placed in AL register. Then 5 and SI plus 1, the content in SI plus 1, that is 2. 5 and SI plus 1, that is 2, are compared, and again 2 is the smallest number, so no carry will be generated. So what happens, this condition will be failed, and we are going for exchanging process. So AL will be 2 and this value will be 5, and for the next instruction, that is move at SI comma AL, this 2 will be copied to the previous location. Okay, now SI is incremented by 1, DL is decremented by 1. Okay, and since it is non-zero value, again we are doing the same process, that is move the content of SI to AL register. Okay, compare SI and SI, so compare AL and the content in SI plus 1. So SI plus 1 is 6. So 5 and 6 are compared. Since 6 is the largest number, there exists a carry. So we get a carry, and we are going for L location, right? So L location, simply SI is incremented. We are not performing exchange. Okay, SI and DL value is decremented. Okay, and then since it becomes 0, this condition will fail and CL is going to be decremented. Okay, so now see, we have completed 2 loops, and the second largest number has placed in the last but 1 position. Okay, so again CL value is a non-zero value. Again we start the same process. We go to L1 position. Okay, where? Yes,
So when we compare two numbers, like when
yes,
we compare 5 and 6,
yes.
okay, 5 is smaller and 6 is larger, right?
No, no,
Then
no,
how
no.
can we know that we get a carry? Like
Uh,
when 5 and 6 are
comparison
compared,
instruction. Yes, comparison instruction performs subtraction operation and the status is reflected in zero flag and carry flag.
yeah, sir.
Okay, if two
Hmm.
numbers are equal, operand 1 and operand 2 are equal, say we have two operands. If A and B are there, if A is equal to B, okay, then immediately the result will be 0. Yes or no? When you perform subtraction operation between A and B,
Yeah, sir.
okay, then 0 flag will be set. Right.
Yeah.
For suppose if both are non-equal, not equal, then if A is greater than B, okay, means the first operand is greater than B, means B is going to be subtracted from A register. Yes or no? B is going to be subtracted from A. Yes or no? Means B is the smallest number here. Right? Do you require any carry for borrow for that? If A is 5 and B is 3, 5 minus 3, do you require
No,
any
sir.
borrow? No. So your carry
No, no,
flag will
no.
be 0.
0.
Yes or no?
Mm.
If
Mm.
A is less than B, okay,
Then we
means
require a carry.
we require a carry. That is what we are performing here, comparing. Comparison operation involves these three operations. Okay, and here result is not affected. Only the status is reflected on zero flag or
Yeah,
carry
status
flag.
is affected.
Okay, now got it?
Yeah, sir.
Okay, so now where we
Ah,
are?
okay.
Yeah, so we are in the second loop. Okay, so in the second loop, since it is non-zero, again what we do, we'll move the value of CL to DL register. Right. So now DL is 2, CL is also 2. So again we are performing the sorting operation freshly in the loop, in the third loop. Okay, so now move AL comma at SI. So now 3 will be simply copied to AL register and compare AL with SI plus 1. So 3 and 2 are compared. Okay, so now 2 is the smallest number. So there we don't get the carry. So this condition will fail and exchange process will be occurred. So what is the exchange process? So 2 will be copied to AL position and into SI plus 1, 3 will be copied, and in the next later stage this 2 is copied to starting position. Okay. Next increment the value of SI. So SI will be incremented, then decrement DL. So DL will be 1, and since it is a non-zero value, again what we are doing, we are going to L2 position. So L2 position, 3 is copied to AL. Okay, so now it is done. Next compare AL and SI plus 1. So AL is 3, SI plus 1 content is 5, both are compared. So there exists a carry. So because the second number is the largest number, so we get a carry and we are going to L location. So SI will be incremented there and DL will be decremented by 0 to 0, right? So now since DL is 0, we are coming out of this L2 loop and CL is decremented by 1. So 3 comparisons, 3 loops are over now. Okay, and since CL value is a non-zero value, we are going for L1 position. Okay, where CL is copied to DL, right? So this will be done, and SI is again freshly assigned to the starting address, and the content of AL, see, AL is moved to content of SI is moved to AL register, and we are comparing 2 with SI plus 1. 2 and 3 are compared, and 3 is the largest number. We are getting the carry. So we are incrementing this. We are incrementing SI. Then decrement DL. So DL, our comparisons over in this loop. Then this condition fails and decrement CL, and this also will be over. So number of loops are also over now, right? And we are coming out of the program. Now if you see the order, your data has been sorted out. Okay, 2, 3, 5, 6, 9. So this is your ascending order, right? So for every one loop, the largest number is placed at the last position. Okay, for the n-1 loop, the second largest number is placed at the last but one position. So like this, the sorting is occurring in our algorithm. Okay, so if you do the reverse process, that is, instead of putting the exchange operation for carry, okay, if we put the exchange operation for no carry, if we put exchange operation for carry operation of carry generation, we will get the descending order. Means the smallest number will be kept at the last position, the next smallest number will be sorted in the next last but one position, like that. Okay, so that will give your descending order, right? And the descending order, you can use a simple change. Instead of JC, you use JNC. If you do this, okay, you will get the descending order as 9, 6, 5, 3 and 2. Okay, so only one change you need to do, and the operation, everything will be the same. Only one change we are doing. For ascending order, whenever there is no carry, we are doing the exchange operation, and for descending order, whenever there is a carry, we are doing the exchange operation. Okay, so hope so it is clear. And in this itself, for the first operation itself, you will get the largest number, or for the first operation itself, you will get the smallest number. So in this way, you can find out the smallest as well as largest number. Okay, so now we will try to implement this in our MASM software. Okay, so for this, directly go to your DOS box, right? Mount. I have written the program, so directly I will be executing the program. Okay. Anyhow, the code will be shared in the classroom. Open it, edit. Since I don't know where I have kept, I will open my file. Yeah. So first file is ascending. See, the program is dumped as such. Okay. So coordinates end start, right? So this is the program what I have used. Save it. Okay, and we'll try to execute the program. MASM ASCEN dot ASM. Okay, so we'll get if it is with 0 warnings and 0 errors, immediately link the program with the object file that is created. Okay, and check for the warning, no stack segment warning, and if you are getting that successfully, go for your debug mode and use the command ascend.filename.exe, right? So unassemble your program right from 2000. So that is the location where we have written the program. Okay, and see, the program is not ended here. So if you want to see the ending of the program, use unassemble after that. So now address location 2023 refers the endpoint of your program. Okay, so now check your data 076A colon. In 1000 location we have written the code, data, right? So 56329. Now simply execute the program from the location 2000H. Okay, so now once you do this, you can see all the registers has been all the registers are loaded with some values. Now, if you want to check the sorted order, display your memory right from 1000. Now see, so 2, 3, 5, 6, 9. It is the ascending order. Okay. If you want to change the data, so I will give you a new data by editing the memory. So 87 first data 34 11 01 and FE. So these are the 5 datas what I have given. Check your display now whether these new values are updated or not. So the new values are updated. Now execute the program. Okay. After execution, display your memory. Sorry, 1000, right? Yes. See, you can see the ascending sorted, ascending order, ascending the numbers that are sorted in ascending order. Okay. So this is about your ascending. So now check. Let us check with the descending order. Edit. Open your file. Right. So see here, I have just changed the small change I have done, that is JNC space L. Okay. So I have not touched any part of the program. Right. So Control S, Alt F, execute. So follow the same thing. Descend.asm. So it will be 0 errors. Link the program. DEC.obj. Okay. Then go for debug mode. DESCEN.exe. Unassemble 2000. Right. Unassemble the program. This try to see your data 076A colon 1000. So in 1000 we have defined. Okay. So this is our data. This was our data 56329. Okay. So for getting the descending order, execute the program. Okay, and display your memory. So now you can see the descending order. The numbers are sorted in descending order. Okay. So if you want to give new data, edit the same memory. Okay. So 34, I'll say some 67, 11, 01, AE. Okay. So these are the 5 data I have given. So I have executed the program, and now check your memory whether the numbers are sorted out or not. So now see, the numbers are sorted out. Okay. So a slight modification means I am going to remove the outer loop. By removing the outer loop in the program, we can have ascending order, means we can have the smallest number. Okay. And by removing the outer loop in the descending order program, we can have the largest number, and that smallest number and largest number you are moving to AL register. So that programs also I will show you. I think no need to explain them separately, but anyhow the video will be shared with you. Okay. So first let us see with the smallest number. Okay, largest number I will check. See here only one loop I am using, that is number of comparisons in terms of CL register, and here we are moving that smallest number which is actually present in AL register, that to 3000 location. So in 2 locations you can find the smallest number, largest number, that is one at the AL register and other at 3000 location. So let us execute this program also. So masm larg.asm. Okay. So it is debug, not debug, link larg.obj, then debug larg.exe. Unassemble the program. I think from 2000 I have written the program. Yes. Okay, and display your memory 076A colon 1000 not 1000. I think I used, yeah, the same thing. Now execute the program from 2000H. Now see, the largest number is present in AL register. AX consists of AH and AL. In AL you will be having 09. Okay, so now display your 3000 location where the largest number is moved. So see, the largest number is present in the starting location. Okay, similarly you can do for the smallest number also, right? So if you want to check the numbers, if you want to give the new set of numbers also, you can do it. Large dot exe assemble 2000. Okay, so you can edit your memory. Edit zeros, not zeros. First execute this program, then edit 1000. Okay, so you can give 87 ff 3423 and 1. So out of this given 5 set of numbers, ff is the largest number. So you can see that in your AX register as well as in your 3000 memory location. Okay, so the code will be shared in the Google Classroom as well as the video for smallest and largest number. Okay, not for ascending and descending. Okay, so ascending and descending you execute now itself. The videos will be shared in the later part.